Okay, let's look at another type of graphing transformation. So given a function y equals f of x, the transformation we're going to look at is letting x go to a minus x. So given the graph of y equals f of x, so for example, maybe we could use a cubic function, can we graph the function y equals f of a minus x? So in the case of the cubic function, sorry, not x, it'll become a minus x all cubed. Okay, so obviously this is a polynomial that you can already graph, but let's graph it from the graph of x cubed using only the fact that we've replaced x by a minus x. Okay, so I'll do it in well, two different ways that are essentially the same, but just doing the same thing in a different order. Okay, so let's do it the first way. The first way will be, well, both ways. We'll start off by looking at the graph of f of x. So this is a graph of f of x, which is x cubed. So there's a graph of x cubed. And what we're going to do is we're going to apply a transformation to get a new graph, which is hopefully closer to the one we're looking for. So if I look at f of a minus x, how can I build this out of f of x? Well, there's minus x, so maybe a good first step would be to replace x by minus x. So if we go from f of x to f of minus x, that's a reflection in the y-axis. So there's our new graph, and we're almost there. I want to draw another graph that is going to get us closer to this. So if I'm looking at this, how can I make this look more like that with a transformation that I know how to do? Well, there's this constant a involved, right? So, and I notice that a has the opposite sign to x. So a has got a plus in front of it and x has a minus. So down here, why don't I replace x by some sort of combination of a and x where they have opposite signs? So I'll replace x by x minus a. Okay, so on this graph I'm going to have f of minus, and I'm going to replace x by x minus a. Okay, and if I replace x by x minus a, that shifts the graph to the right a units. That's if a is greater than 0. Okay, so basically every point will get shifted to the right, so a good point to look at is this root through the origin. So the root through the origin will get shifted to a root through the point a units to the right. And there's our new graph. But if I look back at my function here, I could rewrite this as f of, and if I expand these brackets, I've got minus minus a, so plus a minus x, which is the function we were looking for. So there you go. That's one method to sketch f of a minus x. It's to apply this transformation and reflect it about the axis. So maybe as step 1, I'll say reflect about the y-axis. That's step 1, which is what we did from here to here. And then the next step is to translate or move the graph, translate a units. And I'll say to the right because here I've assumed that a is positive. If a was negative, we would have shifted to negative a here. Okay, so those are two steps to sketch this sort of graph. You reflect it about the y-axis and then you translate it a units to the right. And of course, because we're actually dealing with a formula here, and the resultant formula over here is something that we know, we can check that this works. This is a polynomial. It has a root at x is equal to a. It's a triple root, so we've got this kink in it. And of course, the highest power of x will be the x cubed, and it's got a minus in front of it. So that's why the graph goes this way instead of this way. So there you have it. That's the first method for sketching this graph. The second method, maybe I'll move the screen a bit to give some more room. I'll try and leave all of that there so we can compare. The second method is almost identical, really, but instead we basically do these two transformations in a different order. So again, we start off with f of x, and there we go, cubic looks something like that. And then we want to do our first transformation, but instead of replacing x by minus x, when I look at this last function and say, well, how can I reach that? I say, okay, well, I need to introduce this a with an opposite sign to x. So I come down here and I go from x to, well, let's introduce a, but with the opposite sign to x, so it becomes minus a. So, of course, replacing x by x minus a shifts the graph a units to the right. So there's our cubic shifted a units to the right. So maybe I'll put in this step here. Shift a units, or maybe I won't write shift, I'll write translate just to be consistent with up here. So translate a units to the right. And again, if we had a negative a, we'd be going to the left. Just so you're aware of that. So that was the first transformation. And now our second transformation, we want to move from here to here. Well, I realize that if I want to transform this into this, I just need to change the sign of the whole thing. So I need to replace x minus a by f of minus x minus a. And of course, just like here, if we expand this out, we get f of a minus x, so we got what we were looking for, so this is going to be the graph we need. So the question is, what does this transformation do, going from here to here? Well, we're not replacing x by minus x, we're replacing x minus a by minus x minus a. So if we replace x by minus x, it's just a reflection about the y-axis, but if we replace x minus a by minus x minus a, that's actually going to be a reflection about the line x equals a. So we're actually going to look at this graph at x equals a and reflect about this graph. So we're going to end up with the same thing here. Okay, and that's at a. So we get the same graph. So out of everything that I've done here, I think that this step going here is probably the hardest, because it's probably not clear that replacing x minus a by minus x minus a should just reflect about this axis, right? So maybe what you could do is draw up a table of values with, maybe you could look at 0 and a and 2a and so on to check that going from here to here actually works. Okay, but those are two different ways to do it, and you basically need to remember the steps. You got to either reflect and then shift, or shift and then reflect. Okay. So maybe I'll write that last step down here. Translate a units to the right, and then reflect about. And up here I had reflect about the y-axis. This time I have to reflect about x equals a. Okay. I mean, interestingly, up here, when I reflect about the y-axis, that's actually the line x equals 0. Alright? And interestingly, I can think of this transformation as going from f of x minus 0 to over here becoming f of minus x minus 0. Right? So basically doing the same transformation here, but replacing a with 0, and we see that this reflection is a reflection about the line x equals 0 precisely because there's this 0 sitting here. So that's maybe a way to remember why this transformation going from here to here is a reflection about the line x equals a, because the familiar reflection that you've seen before is just a reflection about the line x equals 0. Okay, so that's two ways to sketch this new graph. I'm going to mention one last thing, which is, if you like, a third way to do it, which is different. But basically, you can just look at the original graph and then come over here and maybe look at the graph we're trying to draw and draw up a table of values like we did in the other video and say, well, I'm interested in not just what x does, but what a minus x does. And you can say what happens as x goes from, say, minus infinity to a, and what happens is x goes from a to infinity. And basically we see, okay, as x goes from minus infinity to a, this will go from plus infinity to 0. So when we're at minus infinity, it's a minus minus infinity, makes it a plus infinity, which is infinity. And when we're at a, we've got a minus a, which is 0. So we've got this. And over here, when we go from a, we go from 0 to infinity. Well, a minus infinity makes it minus infinity. So basically what we're doing is we, in the region from minus infinity to a, maybe I'll grab a different color again, in the region from minus infinity to a, if that's a, we want to look at what happens from infinity to 0. So from infinity to 0. So we see we start off at infinity and we come down to 0. So we start off at infinity and we come down to 0. I haven't drawn that just because I haven't been drawing that bit on these other graphs. And then what happens from on this side, from when we go from a to infinity, so when we go from a to infinity, we go from 0 to minus infinity. So we look at this graph and we go from 0 to minus infinity. So we start at 0 and go down to negative infinity. So we start at 0 and go down to negative infinity. Okay, so I went through that quite fast because it's the same method as in the other video, the graph of y equals f of 1 on x. But it offers another way to think about this, and you can see that we got the same graph as before.